Welcome back to the Deep Dive. Today we're focusing on something that most of us probably ignore until it fails spectacularly, the cable. Specifically, we're going deep into the source material for a professional-grade PureInstall HDMI cable. Our mission is to figure out what actually separates a consumer wire from a high-reliability tool. I mean, what makes a 10-meter cable worth its price tag for mission-critical applications?
It really starts with resilience. That's the defining professional standard right out of the gate. And for a cable, that means the connection itself. In permanent installs or with mobile racks, the number one point of failure is just, well, physical disconnection. So we have to start with the secure lock system, the SLS.
That's fascinating because we've all had that moment, right? An accidental bump or even the cable's own weight just pulling on a port until the signal drops.
Yeah.
How does this SLS thing solve that?
It's purely about mechanical reliability under stress. It's not a friction fit. The system automatically engages when you plug it in. To get it out, you actually have to pull back on this little spring-loaded housing.
Okay, so it locks in place.
It locks. And here's the key statistic. It can withstand up to 25 pounds of retention force.
25 pounds.
25 pounds. That's many, many times more than a standard HDMI connector. So think about what that means in practice. That's the difference between a system that stays connected when someone bumps a display cart and one that just fails. It's all about ensuring zero downtime where the logistics are, complex and expensive.
That physical security is huge. But let's move inside the cable. So the connection itself is solid. What about the ones and zeros traveling through it? What's the engineering that lets this cable maintain a high-speed rating over 10 meters? That's a long run for copper.
It is. The length is absolutely the constraint here. Physics kind of dictates how far you can push data before the signal just degrades into noise. So for 10 meters, the reliable performance ceiling supports HDTV resolutions up to 4K.
So 49:6 by 2160.
Exactly. And that means a maximum transfer rate of 10.2 gigabits per second with a bandwidth of 340 megahertz. You're really at the physical limits for copper at that distance.
To stay at that limit, I have to assume the materials inside are critical.
Yeah.
The source mentions high-purity tinned, oxygen-free copper OFC and 24-karat gold-plated contacts.
Yes. And those premium materials are essential. It comes down to two things: longevity and minimal resistance. OFC copper cuts down on signal loss, which is key for long runs, but it also resists corrosion much better than standard copper. That extends the life of the whole installation.
But I imagine that purity doesn't matter if the signal gets scrambled by outside noise.
You're one step ahead. That's precisely where the three-layer shielding comes in. You have two full layers of aluminum foil and then a braid layer on top of that. This whole structure is about noise rejection. It ensures that when you run this cable next to, say, a noisy power line in an equipment rack, you maintain perfect transmission quality.
So we've got the physical lock, we've got the data integrity. Let's talk about consolidation, because modern cables do so much more than just video.
Right, and this is where it gets really convenient for installers. This cable features an integrated Ethernet channel, or HEC. This allows for bidirectional networking up to 100 millibits per second right over the same HDMI cable.
So you could skip running a separate network cable to a smart display, for example.
That's exactly it. It just simplifies these complex wiring jobs.
And what about on the audio side?
It's built for the highest fidelity. We're not just talking basic sound. It supports the audio return channel, of course, but also the lossless formats.
So things like Dolby True HD and DTS HD Master Audio.
The full cinema-grade stuff, it really future-proofs the entire audio pipeline.
So what this all means for you is that the professional standard is really built in layers. You have the robust physical security from that 25-pound SLS lock.
Then you have the exceptional material quality, like the OFC copper and that heavy-duty triple shielding.
And all of that works together to enable that reliable 10.2 gigabit per second transfer over a full 10 meters.
Yeah, and what's so fascinating is that even this premium copper solution, it still tops out at 10.2 gigabit per second at that length. So it raises this important question I want to leave you with. As 8K video demands way faster speeds, what's next? What material science breakthroughs or signal boosting tech would we need to push those signals over long copper runs without just having to switch over completely to fiber optics? Something to consider.